You're welcome to my channel, Mindset Academy, where we want to solve a problem involving interpenetration. Now, we'll be looking at the common intersection between two solids, and both of the solids are what? They are pipes, just like you can see at the right hand side of the screen. We have a smaller cylinder penetrating a bigger cylinder. But in this case here now, they don't have the same center, right? They are offset. Their center are not coinciding. That is, the smaller cylinder is tilted, is shifted to a particular side of the bigger cylinder, so it is not centralized. So first of all, before we can draw the curve of intersection of these two cylinders, we need to reproduce the figure that is displayed at the right hand side of the screen, right? So the top here, it is in third angle projection. The top here is the plan, and here is what is the elevation, right? So first of all, let me start drawing from the elevation, or better still, I start drawing from what? From the plan. Is that taken out? So what I'll just do is I'm going to take my meter rule, right, and I'm going to draw my horizontal line in this manner. You can see that. And also I'm going to draw my vertical line in this manner also, right? Let me break it down a little bit. I'll draw my vertical line in this manner too. Now once I have done that, this is the center of the circle here, right? And the diameter of the circle, as you can see, is given to be what? 70, meaning my radius is what? My radius is 35. So I'm going to take my meter rule and I'm going to measure 35 on my meter rule. So I have 0 to 35 here, as you can see, right? And I'm going to place it at the center point here, and I'm going to draw this way, as you can see here. Right, so this is what we have here. Is that taken? Now the next thing I'm going to do is to draw. This is the base of the bigger pipe. Now this is the center here, and the smaller one is offset 8 millimeter away from the center of the bigger one, right? So I'm going to draw 8 millimeter away. So this is 8 here, right? That is where the next center is. Now I will just project it outward in this manner. Bent line first of all. So I'll project it upward in this manner. You can see that. And from that point, the radius of the smaller circle is given to be 20, given to be 27, right? If you can check at the elevation, you realize that we have diameter of 54, meaning the radius is what? Is 27. Having in mind that these two figures are the same figure, but in different elevation. Now, I will now take my meter rule and I'll measure 27, which is the half of 54. 0, this is 27 here, right? And I'm going to place it at this point here. Is that taken? I'll place it at this point. I'll just place it this way, and I'll mark up and down. You can see from here to this point here. Can you see that? And I'll just draw my line this way, faint line from this point outward, then from this point outward again. I'm using faint line because I'm not sure the extent of what of the line, right? So I'm going to leave here this way, and I'll come to the elevation. I'll come back to this. So let's move toward to the elevation here. Now if I project the edges, the ends of the circle, which is the base of the bigger circle, if I project it this way, faint line, and I project this one to this way, faint line, right? Now I'm going to draw this. I'll thicken it since I know that it's from here to here as shown in diagram, and also the total height from here is given to be 120. You can see that from here to here is 120, and I'll just close it up. And I'll close it up too. Can you see that? Now, before that, we're told that at a height of 20, we'll get the center of the circle, of the smaller circle, at an height of what? 20. So I'm going to measure an height of 20 here, this way, and an height of 20. Then I'm going to get the smaller circle. You can do it in two ways. Either use a 45 degrees set square, right? Or you just draw your line this way, in this fashion. All good? Let me use 45 degrees set square, this way. Let me use 45 degrees set square this way. There is my 45 degrees set square here. So I can just move this to that point, place it into my T-square, and I'll draw a line this way. I can easily extend that line, faint line. You can extend it this way. You can see that? Now once I've done that, we're told to the distance of the pipe from the center here to this point is given to be what? 88, right? So I'm going to measure 88 from here, from 0 to what? To 88, and this is the 88 here. So to be at that point, since I projected with 45, I must counter it with what? 45, so that to attain a perpendicular line in this fashion, right? So what I'll do next is, we're told this 54, the diameter, mean radius is 27, so it means that from this point to this point, which is 27, I'll come here. I'm talking about this point to this point here. Can you see that? Or you measure half of 27, which is that's 27 here, half of 54, and you place it here, and you mark at this level and at this level here, and you use your 45 degrees set square, and you close it up, right? I'll just place it this way, and I'm going to close it up, and I'll come here also. I'm going to close it up too. And I'll close it up too. Right? So I can easily close this place up and this place up. You can see that. Now I can come back to my plan here now. So at this point, I'm going to project this upward from the center here. Faint line, right? So meaning that this will be thickened to this point, and this will be thickened to this point, first of all, right? So if you notice my diagram, there's an elliptical shape here. So how do we get that? This is what we are going to do. Very close to this, I'll draw a line that is close to it here. Let me just come here and I'll project these two ends up. This and this. You can see that. Then I can come to this point and I'll use this, draw a line, or better still, draw a perpendicular, a line parallel to this point here. Is that taken? So from that line, I'm going to take this measurement of this, the radius of this pipe, place at the center, and I'll draw a semicircle this way. Right? So when I place it here, I'll cut here. When I place it here, I'll cut here. And when I place it here also, I'm going to cut up and down. So this point, I'll move it towards the center. This, 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 and this. So I can decide to say here is 3, 2, 1, 0, 1, 2, 3. I'll come here also, I'm going to do the same thing, but this time I'll place it away from this line here that comes from here. Let's say at this point. Right? So once I do that, again, at the center, this is the center here, I'm going to draw a semicircle at that point too. This is the semicircle here. And I'll do the same thing from here. I'll mark. From here, I'll mark 2. From the center point here, I'm going to mark up and down. And I'll move this point towards the center of this semicircle here. You can see that. Now if the vertical line here is 3, meaning that the vertical line will be what? 0. This will be 1, 2, 3, 2, 1, 0. Is that taken? Now after I've done that, I will now move each of these points to touch this surface here, or better still, I'll move each of the points to come and touch this horizontal line here, this vertical line here, using my 45 degree. So if I come here, if I use this, right, I can just come here, use the first one here, then the other one, to move from here to here, then this, we move from here to here, then the next one, we move from here to here, and the next one, we move from here to here. Right? Now this is what we have. So it means that this point is point 3 here, point 2 here, point 1, point 0, 1, 2, and back to what? 3. All these points you see here. So this point, I will generate them up. Right? So from this point here, I'll move them up. So if I move 2 now, move 2, then I'll project 2. This is, I have 2 here, I have 2 here, right? So I'm going to project 2. We put 2 here. Now let's see. We had 3 earlier. This end line and this line, they are 3. So when I move 3 up, this is where 3 is meeting 3. The other 3 too is meeting 3. 3 is meeting 3 here. Similarly, if I move 2 up, I need to project the line of 2. So this is 2 here. When I project 2, I'll project the other 2 here also. So let's see. So 2 is coming up, meeting 2. Right? Also 2 here is coming up, meeting 2 here. I'll come again, I'm going to project 1. So I project 1 here, and the other one here. Now let's see. If I put the 1, this one will have 1 here. We also have 1 here. So let's see. This is 1. 1 is coming up to meet 1 here. And also 1 is coming up to meet 1 here. Right? And we have another one again. 1 is meeting 1 here. And also 1 is meeting 1 here. Is that making? Don't forget that 2 also, this 2 here is also meeting 2 here. And this 2 here is also meeting 2 here. Now the last but not the least is 0. This is 0 here, coming up to meet 0 at this point, and coming up to meet 0 at this point. So this is the shape I have here. So I use my French curve. I'm going to join all those shapes together. Right? So when I do that, I will have this. And when I do that, I'll have this. I'll come here too, I'll do the same thing. I'll have this. And also, I'll have this. Can you see that? So this is the shape that is shown in the diagram, as you can see. Now I've successfully drawn how the plan will look like, because when you're looking at it from this side like this, from the plan, you're going to see the circular top because it's a cylinder, right? Now the next thing is the curve of what? Intersection. Is that taken? Now all these points here, if I generate them to touch the circumference of the circle, let's see. This will come to touch here. This is coming to touch here. This is already there. Then this also is coming to touch. And this is coming to touch here. All these things are what? Are points. Right? So I can call this to be point 1. This is 0 here. This is 1. This is 2. This is 3. This is 2 again. This is 1. And this is what? 0. So all those points, I will bring them down. So let me start with 0. Once I take 0 down this way, right, where 0 meets 0 is at this point. Can you see? I'll come to 1 again. From here, I'll take 1 down. So I bring it down. Where 1 meets 1, this is 1. 1 is meeting 1 here. Right? And 1 is also meeting 1 here. I'll come again to 2. Right? If I come to 2, this is 2 here. This point. So where 2 meets 2, this is the line of 2 at this point. And this is the line of 2 at this point. All together. Now the next thing is we have 3. This is 3 here. So if I bring the 3 down at this point, so this is 3 here. So this point here, all these points here are what? Are 3. Right? This is 3 and this is 3. So this is what we have here. So I'm going to join all those points together first of all here, and they will be what? Thickened. They'll be thickened. You can see that? I'll just come from here. Right? And I'm going to take this. So this is what we have there. That point you're seeing is what we call the curve of what? Intersection of this particular pipe here. Now the next one is, at this point here is 0. Right? 0 is meeting 0. Look at the line of 0 at this point. All together. So 0 and 0 is meeting. Is that taken? So while it does this, I'm going to connect from here to this point with hidden line, because you cannot see the other side of the pipe. This side you cannot see it here. If you're looking at it from the base here, so I'll have this way. Then I'll close it up. And I'll close it up. Right? Now let's come here. And I'll close it up. You get logic? So this one we cannot see. That is why we are using the kind of what the front line here, right? So this is what we have. This is the pipe, the smaller pipe that have intersected the bigger pipe, but it was shifted to one side, right? So the pipe is shifted to one side, not really centralized, because the pipe has its own center. This is the center for the bigger pipe. The center for the bigger pipe, and this is the center for the smaller pipe, right? This is the center for the bigger pipe. You can see that, and you can virtually do this the same thing too. All these are centers at this point. They're taken. So we're successfully produce this figure, and don't forget to put in your dimension in also, because we know that from this point to this point it's given to be 120. Is that taken? So I can easily write out my 100 and what? 120 at this point here. 120. And we know very well that this particular circle here, the center, is given to be diameter what? 70. Right? And we know also that the distance from this point to this point here is given to be 20. Size from here to here is 20. Then the distance from this point here, from this center point here, right? Let me take it up a little bit. From the center point to somewhere around here, right? Given to be 88. That again, then this here, this to this point here is given to be 54. Is here 54. the diameter in front. So this is what we have here. So if you found this video helpful, please don't forget to like, subscribe, and also share the video. Thanks for watching.